The stream is live.
Hello, and welcome to the very first episode of Get Kafka-Nated, a show digging into all things Kafka from its early days at LinkedIn to the latest and greatest kits. I'm your host, Hugh, a community organizer and developer advocate specializing in all things Kafka at Ivan. In each episode, we'll dive into a new topic with a different guest speaker from within the Kafka community, helping us all to get our Kafka and coffee fix. As promised, there's a coffee on us. You'll find the link to claim your voucher in the chat now. Just a quick note, it's only available in Europe and North America due to some regional limitations. We're working on making this offering more widely available next time. All right, let's get into it. I'm thrilled to welcome our first guest, Head of Cloud Data Streaming at Ivan, Filip Yunov.
Hey, Hugh. Thanks for having me. It's a bit late where I am, so I'm already past the hour for coffee. And I just want to mention something. I feel almost overdressed, but I was kind of like participating all day in our product offsite. So apologies for me not having like a cool T-shirt like I usually like to have during those things. So maybe a little bit about me. I do Kafka. This is what I do. I've been doing Kafka for almost 11 years. I will probably continue doing Kafka for the next 10 years. I started with 0.7, and ever since then, I've been working in different capacities. And my latest gig is kind of running the streaming domain at Ivan. So I'm really, really happy here is to be like the first guest in this new show. And actually, really excited to talk about Kafka.
Fantastic. It's great to have you here. So just kind of a warm-up question. So you've been working
Yeah.
with streaming systems, as you say, for like a decade. What was Kafka like when you first encountered it?
It's both very different and it actually very similar, right? And if we actually want to go back in time, we must understand kind of like what made it so great and kind of like why it was conceived in the first place. I practically grew up with Kafka. This is like my career journey for better or worse. If you ask my partner, she will say that probably is one of the best things in my life, but I have some opposing views. Having said that, Kafka was conceived as a big data ingestion engine. This is where it actually started and it still shines. So it was created to overcome problems of scale, of durability. It was also conceived in the world of the data center. So actually, it kind of like overcame several data center generations, and now we're using it in the cloud. But back in the day, the cloud wasn't really a thing, and Kafka was designed around, for example, local disks. And Kafka is a storage engine, big data ingestion storage engine. So in this case, most of the design principles were around how do we overcome hardware failures. So a hard drive overheating or like failing. How do you ensure that you never lose data? How do you ensure kind of like you have these automatic and elegant backups, which we basically call replication in our world, right? So long story short, back in the day, Kafka was conceived and used especially at large-scale data ingestions, for example, for clickstream ingestion, for all sorts of kind of like very high-velocity streams, which eventually get used downstream in your kind of like IT stack for subsequent analysis, notifications. Also, this was the time, actually a few years later, so 4 or 5 years after, this was the time of the microservices revolution and breaking down the monolith, right? So you could have these loosely coupled, fault-tolerant, smaller services which needed a communication layer to basically exchange information. And Kafka was probably the perfect tool, right? And Kafka started slowly evolving into this kind of distributed event mesh or distributed event bus. This is, by the way, funny enough, in a previous job where I was working for a major bank, this is how we called it internally, the Kafka clusters, event buses. So long story short, at this stage, Kafka grew into more of a repo for data, kind of like transient data, right? This was kind of like where we actually went. We went from big data ingestion, kind of overcoming scaling limitations of historical queues, overcoming the disk failures, into something which is kind of more of a network for high velocity or near real time data. And this was the time actually when we get into the cloud innovations and more elastic environments. Also, Kubernetes already started picking up over the last 4 or 5 years, etc. But I can talk a lot. Maybe we can actually discuss a bit more on some other things which are interesting.
Of course, of course.
Yeah.
I was fully stunned learning about Kafka there. It's interesting thinking, obviously for me with my career with Kafka has all been post-cloud. It's really interesting thinking about like a world in which Kafka is existing in like an on-prem environment. Like how much do you feel that the birth of Kafka being in on-prem and in physical environments has influenced Kafka since? You know, like how much of modern day Kafka is living with the legacy of worrying about things like hard drive failure and losing network and stuff like that?
Yeah. Well, you know that we talk a lot about diskless recently and like this KEEP 1150 and all this. In a nutshell, the biggest legacy of Kafka is actually the replication mechanism, right? I talked about one of the superpowers of Kafka is actually ability to automatically replicate to, for example, additional brokers or servers. This is kind of like the atomic unit of account when we talk about these types of fault domains. In this case, basically, Kafka relies on additional machines or horizontal distribution, as many other horizontally distributed engines, which are quorum-based, to kind of like keep your data safe, right? And this was effectively lifted and shifted in the cloud to the very day the official open source distribution of Kafka is using this mechanism, which is, I don't know, 10, 11 years already old. And I just want to mention something which is very, very important. When we were conceiving 1150 and we were having those endless discussions with the engineers, we started with like, Kafka's replication is old. No, it's not old. It's actually very, very, very elegant system. It works extremely well. It saved us from so many incidents in the past and in the present. The problem with the replication mechanism is that cloud data transfer fees, which kind of like account for this type of replication, are extremely taxing. So it's actually not old. It's just expensive.
I think that's like, yeah, super interesting, particularly around that piece on like how replication has stuck around, but you know, it's worth keeping. I think you mentioned there around like KIP 1150. I think maybe it's worth like taking a minute just to dig into that for people who haven't come across it yet. Like we've had some. So I guess quickly just covering it. So obviously a KIP is a Kafka Improvement Proposal. So these are like the open source. This is the open source process of making improvements to Kafka. We've had some major shifts in Kafka with things like KIP 500 removing Zookeeper recently, even going all to Kraft, and KIP 405 bringing tiered storage. You know, as a product leader, like how do you evaluate the kind of impact of these sort of big architectural changes? And I think also, you know, with KIP 1150 coming, how do you feel about that?
Yeah. All right. So I would suggest let's start with KIP 500, right? The Zookeeper. I hope this will be extremely boring because this is intended to be boring when we talk about zookeepers. Basically, this was a necessary modernization, right? To run Kafka, in the past, you actually needed two adjacent systems. The first system was Kafka itself, and the second system was a quorum of, zookeepers. You needed also to deploy them, ideally in 3 or 5, kind of like a hot set configuration to achieve, again, the same durability for your cluster, etc., etc., etc. This naturally created like almost double the work, right? In many cases, actually, the Zookeeper itself, the Zookeeper quorum had problems and creating problems for the Kafka cluster, or vice versa. And also pose some scaling limitations. For example, given that the Zookeeper quorum is managing the metadata of Kafka, it imposes, for example, partition limitations, some other things. I don't want to go into these details. But long story short for us is that it was extremely boring upgrade. I just got a word that we are already GA grade at Ivan, so probably in the next couple of days we will be launching on the changelog. But this was exactly the aim. This is a supporting system to begin with, and this needs to be extremely trivial and boring for anyone which deals with Kafka. And especially for customers of a managed provider like Ivan or any other out there, this should be absolutely zero impact on their day-to-day. It must not be something which they even think about, simply because, first of all, this is a non-functional grade, right? Kafka does not change its behavior. Functionally speaking, it just kind of like gets some additional scaling from here and there, and more important, just kind of absorbs a coordination mechanism which should have been done a long time ago. So this is KIP 500. Very, very boring, extremely complex, but very, very, very boring thing to talk about. Now, the second one, which is far more exciting to me personally, is tier storage. I think it's one of the most underrated features out there. Before we get to the diskless Kafka and to the cool stuff, I don't know. Some of the people in the code today know that we already had kind of session at Current with Francesco about talking about like our lessons from tier storage and how we implemented it at Ivan and all of this. But the long story again, shortening the whole like story about tier storage is that it's just bad. It makes Kafka better in every dimension when we talk about cloud deployed Kafka. And why is this? Simple, because Kafka is a stateful system. Tier storage allows us to actually store less of the data on the cluster itself and leverage an elastic object storage like AWS S3 for the bigger part of the data stored on the cluster, which makes everything easier. So all the metadata operations, cluster upgrading, scaling, downscaling, all sorts of additional operations, and even throughput per machine are beneficially improved. And one of my missions have been during my calls with prospects, with customers, with friends, is kind of like, please adopt tier storage. It will make your life on Kafka easier. It will make your life actually on Kafka safer, because many things actually work better.
Tier storage is such a cool technology for the things it enables you to do in terms of like running Kafka at scale. Like, having been someone who's operated Kafka before, it's been super useful.
Yeah.
On that point around tiered storage, though, if I'm someone who's already adopted tiered storage, why should I care about KIP 1150 and diskless Kafka?
So to understand why you should care, I want to talk a little bit more about tier storage first, and then we will go into the completely diskless approach. First and foremost, we need to understand how actually Kafka is being used. In our implementation of tier storage, we already have we're close to 100 clusters, by the way, using tier storage. We saw a very kind of robust pattern that in almost 95% of the cases, backfills and rereads are not a thing. So very, very rarely somebody will hit a reset offset or a topic flush, and then they will kind of like reread everything and etc. on the cluster. Basically, data just lands and gets read immediately or almost immediately, and nobody really will rewind it. So what does this mean? It means that we can already think about extremely aggressive tier storage implementations for Kafka. And when I talk about aggressive, it means that to store very few gigabytes or bytes on the cluster. And I already have kind of like a recipe in my back pocket, which I always try to demonstrate. So if you want to adopt or try out tier storage, first start with 3 days of local retention. If you have 7 days, it means that 4 of those days will go on object storage. So you locally will retain 3 days. Then you can actually see if there is no lag and you don't have those frequent rereads, which most likely is the case. You can actually try to go to 8 hours. 8 hours is a good amount of local data, because then it means you can kind of like be for the full workday. So you can react if some lag is experienced. But again, as I said, it's very unlikely. Then you can go to 3 hours and eventually 15 or 30 minutes. We are already in many cases at 15 minutes local retention, and this has been immensely beneficial. I'm talking about 10 to 15 times better scaling, for example, or downscaling. Also removing the need to scale simply because the broker is healthier to begin with, meaning that they can actually process a bit more throughput. So what we did with tier storage already in our journey is that we're retaining probably a percent and a half of the total data you would actually retain on a given Kafka cluster. And this is already a major achievement. So when it comes to storage, it's almost a solved problem in Kafka with tier storage. The problems which Keep 1150 solves is the last 1.5–2% we can carve out from the brokers, and the other problem, which is of course the networking on certain clouds. So I just wanted to make sure that we compare and contrast that tier storage really solves the storage problem, and Keep 1150, even though it talks about storage in diskless, solves a little bit different problems. Yeah,
definitely. That makes a lot of sense, right? Like the slight nuance there between the two use cases.
Yeah,
both of them let you do so much stuff, and particularly in cloud environments, you can have some pretty significant kind of savings and stuff like that. But there's always a tension between these bleeding edge features and like production stability, right? Like,
absolutely.
How do we balance innovation with reliability with these new kits?
Yeah. So, all right, let's continue this journey. I think that's great. So let's assume that we already kind of like tiered our Kafka cluster. We're enjoying lower costs on storage. We're enjoying a healthier cluster because we just upgrade faster, right? So we have less issues. Now, what can we do next? What can we do about our operations, and what can we do about kind of like our cost profile and our cloud bill? So Keep 1150 was kind of created with the intention of economics, fixing the Kafka economics. Clouds like AWS and GCP are more taxing like clouds, for example, like Azure, when it comes to networking traffic or data transfers. This is just the cloud economic model, right? So we started with the same intent. Let's make Kafka cheaper, right? That was the original intent. However, very quickly we realized that actually economics is just the tip of the iceberg, because the moment you remove all of the storage from a broker, this broker can, for example, behave more and more as a stateless software rather than a stateful software. And in our Kafka world, this is a novelty, right? Suddenly you can use Kubernetes, which is kind of like the benchmark for stateless workloads management, to spin up and down clusters and brokers in a matter of seconds, and in certain cases, even in a sub-second manner. We also figured out that, hey, if we're leaning so hard into object storage for our storage and balancing needs, because the key distinction is that diskless basically delegates this replication mechanism, which I talked about in the beginning, to object storage itself, right? We kind of like say, hey, the object storage has enough durability already, is very well kind of it's very safe, so we can kind of like just piggyback on it, and we can slipstream into the shadow of those engineering efforts there. So we don't really need to care about durability on the compute level. It turns out that we can actually do more, because the storage level, the kind of like the object storage level, is a load balancer, a networking layer, a storage layer, all rolled into one very easy to use, very ergonomic API. And I'll give you an example again. Suddenly, we have capabilities to deploy multi-region clusters. So one object storage bucket can be shared by multiple brokers deployed in different regions. And then you basically have one cluster boundary across different regions, which will have the ability to replicate the data in a very redundant, very kind of safe way, with a bit of latency. I think in S3 right now is 15 minutes, but for almost 95% of the use cases, 15 minutes of kind of replication lag is very, very good for an active type of setup. So this, for example, with 15 minutes delay, again, brings us a very interesting benefit that it's almost 85% cheaper than just, like doing a classical active, which is extremely costly, as you know.
That makes a lot of sense. It's particularly interesting, like how much of these decisions to like bring these kits forward to improve Kafka and add these new features are like informed by the economics of the cloud that Kafka is running in now, right? Do you think we would still be looking at making these kind of architectural changes to Kafka if it weren't informed by the costs? Like, does writing to object storage for your Kafka data have benefits beyond just saving on your cloud bill?
Yeah, I think that it's a very interesting world we live in, right? In the Kafka world, every time when we take up on a cost-cutting initiative, right, or some sort of an efficiency initiative, this usually translates in ergonomics gains. This is how actually usually is the dynamics. And I'll go back to this statelessness kind of like benefit that suddenly we can have fully elastic dedicated Kafka clusters, right? It's very little known or talked about, but full elasticity in the current classical Kafka world is something which is missing, or it's partially available. Let me be a bit more precise here. Simply because it's so difficult to kind of have instant scaling up or scaling down on a dedicated Kafka cluster. So all of those serverless solutions out there which offer this type of behavior are actually slices of a larger cluster. So basically they're kind of like oversubscribed mega Kafka cluster, which kind of already the resources are there and they're kept hot for you, so you can just get more topics or get more traffic or whatever. So when we talk about economics, this immediately translates into gains on the behavior of the system and much better, let's say, user experience ultimately.
Awesome. So we've spoken a bit about some kits that are already in main Apache Kafka, so removing Zookeeper, tiered storage. Diskless is on the way, and there's a a preview of that from Ivan with Inkless. Looking forward and thinking about Kafka in the next year, 2 years, 3 years, what are you excited about? Like, what kits that are coming and what products and changes to Kafka that you think are really going to change the way we work with Kafka in that sort of time scale?
Well, I cannot help myself. I'm gonna say keep 1150. Basically, putting object storage as the primary log of Kafka, right? And I mean, as I said, like, why is it exciting, right? It kind of like unlocks fully diskless, right? We're enabling ultra cheap storage on S3 GCS. It simplifies everything, as I already mentioned, eliminates the need for local disks. And by the way, there is another hidden kind of like solution behind all of this. Let's say tomorrow the cloud providers will offer a magically replicated EBS, which kind of like shadow replicates, and it's super efficient. There is certain kind of like capability right now, but you still have like 15 to 30 minutes of an SOA, which is usually not a great spot you want to be. But let's say they achieve it, right? Then basically what we will have is choice. We can actually go back to local disks and replicate there, and Kafka will be able to survive or overcome whatever pricing model the cloud kind of like institutes on it. So I'm really excited because this provides us as a community optionality, right? It provides a way for Kafka to kind of like surf the cloud instead of survive it. The second thing which I'm very, very excited is KIP 932. It's called, I think, virtual clusters, or I think it was cluster-wide resource isolation. I'm just quoting by memory. Basically, this is multi-tenancy in disguise. One of the tricks for Kafka is that building a serverless multi-tenant Kafka is really about the Kafka, not the infrastructure. So if you want to enable true multi-tenancy, you actually need to work on Kafka, not on, for example, something like Kubernetes or the infrastructure underneath it. So can we actually enable a single Kafka cluster to serve hundreds, if not thousands of tenants, right? And yeah, I'm really, really excited. I'm currently onboarding to this KIP just to read into kind of like how the ACLs work and the authorization mechanism and the isolation. And yeah, it's really like a foundational thing which will enable, for example, large infrastructure teams not to implement their own hacks when they want to kind of like provide true multi-tenancy. The other one, and I'm actually, this is something which I noticed also at Kafka Current a month and a half ago. The only room I couldn't get into was the discussions about Kafka queues. So I think it's KIP 898 exactly. Um, it was so busy that I just gave up on the entrance. We're seeing something which I believe is extremely needed, and I think it has a lot of future with Kafka going forward, is adding queue-like semantics to Kafka. For many, many years, Kafka has been replacing messaging queues, but it has been replacing them in a very kind of like almost hacky way, right? I myself decommissioned several typicals and several RabbitMQs and IBM-MQs in my career in favor of Kafka, but this was always in favor of some hacks. So per partitioning ordering, some sort of game with the consumers and whatnot. If we are able to natively support this kind of like a walkie-talkie thing and kind of like exactly ones and all these goodies which Kafka queues actually bring to the table, this will really, really simplify the overall semantics for Kafka and kind of finally open the doors for these systems to onboard. And last but not least, these cleaner semantics, especially for non-partitioned workloads and agentic use cases. Why not? I'm really, really excited about this. And I know that this is an accepted KIP, and I hope that we are very, very close to actually getting it. So yeah, I can talk more, but actually I wanted to ask you, what are your KIPs which are you excited about?
That's a big question. I definitely potentially overhyped, but obviously Iceberg is kind of the hotness at the moment. I was very lucky to participate in a workshop about Iceberg over at Pilot London a few weeks ago, and it was really interesting seeing that as a way of lakehousing data and working with data at very large scale, doing time travel and stuff like that. So for me as a data engineer, that was super exciting. So I think for me, I'm looking forward to KIPs, which I'm terrible with remembering the KIP numbers, but looking forward to KIPs where we're seeing increased Iceberg support. Is it necessarily where the whole industry is going? I don't know. But I'm really excited to see like increased support for Iceberg in various places, so we can start experimenting with these new use cases and seeing what works. I think Lakehouse is still like this really important model, and particularly with all of these AI workloads and stuff coming through, like there are some really cool opportunities to experiment with things and see what works.
Yeah.
We actually had a. Oh, sorry. I was going to say we actually had an audience question. But I want to sneak it in under the radar. Otherwise, we'll talk about KIPs for the rest of the time.
Sure.
A question from Anand: is there a plan to have a REST API to produce in Kafka? I know some independent vendors offer this solution.
Yeah. Ooh, that's a loaded question. I actually recently posted some ideas on LinkedIn. Let's take a step back here. There is already a REST proxy you can use today. There are probably 50 REST proxies out there for Kafka, but all of them are kind of carrying this baggage of Kafka itself. So behind the scenes, you will have a Kafka producer, a Kafka consumer, or both, right? To mimic your kind of like producing and consuming. Where I am actually seeing a problem, or actually several problems. The first problem I see is actually coming from the virtual clusters kind of like discussion. Kafka handling hundreds of thousands or thousands of kind of connections is usually painful. It's just something which Kafka wasn't designed. And this is going back to your original question about the roots in the data center. We never really considered million clients Kafka, right? Probably will happen in the future, but this was not how it was designed for. Actually, I had this kind of like a very good saying I heard the other day. I'm a very interested in concrete. I'm doing some repairs at home, and they say that the good concrete is good at being stomped, but very bad at being stretched. So in the same kind of like train of thought, Kafka is very, very good in terms of throughput, right? But it's very, very bad at actually connection limits and like maintaining million of handshakes with different with a variety of clients. So the first problem is actually connectivity and maintaining or delegating the connectivity to somebody else, right? And also this is achieved one of the chief problems of multi-tenant Kafka. The second problem is the producer and the consumer model itself. Regardless of how easy to use is a Kafka system, let's take the most modern serverless per topic as a service types of products out there. They still expect you as part of the journey to have a Kafka producer and to have a Kafka consumer. There have been a very, very strong evolution in the different kind of like supported languages. Of course, Java is chief of them. Python also, we have a Go, we have many others. However, this kind of like added complexity and the clunkiness of the model is sometimes a turn off. So I've been thinking about like, what if we just strip away all of this and kind of like offer this as a simple JSON? So basically, in my head, currently, I'm thinking like, can I have just a send button and a receive button or a read button and call it a day, and I can just kind of like shape my message as a simple JSON? So in order to actually get into this, we need to rethink the whole proxy layer to begin with and eliminate most of the baggage. So to answer Anand, like these are the problems. The solutions, we are currently working on with the team on something very exciting, and we'll be announcing more about it in the next couple of months.
Amazing. Yeah. So I think, yeah, definitely, there is right now there is the features and the tooling out there to do REST on Kafka, but the question is, should you be doing REST on Kafka right now? But yeah, definitely watch this space. One final question before we wrap up.
Sure.
If you were explaining Kafka's kind of historical significance, I think we touched on kind of the roots of Kafka and Kafka kind of undergoing this metamorphosis to really work in the modern cloud. If you were to explain the significance of Kafka to a developer just starting their career, why would you tell them? What would you tell them to sort of explain why this project matters? I know you said that Kafka has been very important to your life and your career.
Yeah, I'll actually turn it around a little bit. I love to ask this question, especially for interviews, and the people who interviewed with me probably know and remember this question. I always ask people, what makes Kafka so good? And I love this question because every person out there has a slightly different answer. If it's an engineer, usually they come from, like it's durable, it's replicated, it's actually very well thought out. There's a million lines of code there, right? Or whatever. If it's a more business person, like it's adopted, it's real-time data, it's kind of like very fast, etc. So I think that it's all of them, but more importantly, Kafka has achieved something which very few kind of like open source projects achieved, which is it has compounding networking effects. The first networking effect which Kafka enables is Kafka is all about connectivity, first of all, right? So you want to kind of like connect different sources and you want to connect different destinations easily with the same standardized API, with most of the time with the same cluster. So you don't really need to, shuffle around clusters and figure out which is your source and destination. But the real power and the real magic is when you start linking topic after topic after topic, so producer to consumer, etc., to achieve, for example, a pipeline, right? So the world will be much less rich place if we didn't have this at scale. That's number one. But more importantly, number two is even more powerful network effect. Every time a company adopts Kafka or a Kafka-like system, most of the time they also need to invest in engineers to work with the system, and more engineers means more contributions on the open source. More contributions on the open source means a higher quality product. Higher quality product will actually result in probably more adoption and a better experience for everyone. So this is kind of like, again, a very virtuous cycle which compounds. And last but not least, some of the upcoming work which we will be doing is trying to again compound these networking effects by, can we actually really make Kafka almost ambient, right? And easy to connect, so that we can include, for example, AI agents or short-lived functions. We were just discussing earlier with the engineering team that in some cases nowadays, certain pieces of software live for just a couple of seconds. Can we actually accommodate these types of very kind of like millisecond type of operations, which just are so ephemeral that you can measure them in the milliseconds? I think this is where the third wave of networking effect will actually lie for Kafka.
Amazing. Really, really exciting stuff. So thank you for your time today, Filip.
Sure.
I feel like we could talk for a lot longer about Kafka, and I'm sure we will. And thank you to everyone who joined us live for a cup of coffee and some Kafka. Join us next time for a session where we'll deep dive into all things open source Kafka with longtime contributor to the project, Joseph Pratt. If you've got a topic you'd like us to cover, or would like to participate in the show, or have any feedback on this first episode, such as it is, drop me a message over on LinkedIn. Thank you all for listening, and see you next time.
Thank you. Bye.